Today was one of those unique days where I biked in this morning, and there was actually a little bit of a struggle to find a bike slot. So it's great to sort of see the students back on campus and people taking advantage of the great greenway trails we have in Central Ohio. By the way, I think Larry Peck's here and some of the Metro Parks people, there is a bond issue this fall, so I'm sure they appreciate your support with that. Thanks for joining us this morning. This is a great time to be on college campus in the fall. At the beginning of the semester, with so many incoming freshmen, grad students, and others returning, it's just wonderful to see sort of like how campus comes to life and the enthusiasm and energy that returns to the campus after a long summer. We actually have about 750 high-performing undergrad students that have joined the School of Environment and Natural Resources, in addition to an array of wonderful environmental programs at Ohio State University and, let's say, Earth Sciences, Civil Environmental, Geodetic Engineering, and EEOB. So we have a great portfolio of wonderful students returning this fall, and I'm delighted to have many of them here today with us as well. It's great as well to have a couple of our SENR student ambassadors here working as part of the team, trying to share a little bit about, or guide you in here and share a little bit about the school. Kalia Telez and Jonathan King were part of the team and welcomed you at the registration table today. I want to personally welcome all the newcomers to the EPN among you, and as a reminder, if you'd like to learn about future EPN events and receive those notices of the monthly breakfast programs, it's quick and easy to sign up at epn.osu.edu. It's free, quick, and easy, so please consider signing up if you haven't already done so. We have a great array of programs scheduled for this year, so we're excited to include you in those future events. To review our activities of the past summer and some details now new to our 2018 fall academic semester set of programs, our EPN director, Joe Campbell, has put together a welcome back video, which is available on your Environmental Professionals Network YouTube page, which you can access via epn.osu.edu. If you've watched the video, you'll know about some of our new additions to our EPN breakfast programs this year. One of these new additions is the opportunity to sponsor a student. I'm excited about this one through our online registration page. This option is available to all of the environmental professionals out there who, for the cost of only $10, can sponsor a student participation in an EPN breakfast. Please turn to the back of your program to read the professionals in the audience that chose to sponsor today's participating students, who, along with the School of Environment and Natural Resources, have made registration free for all the students attending today. So on the back of your program, it lists about 18 or 20 folks that did that, and we very much appreciate that, and hopefully the students have a wonderful experience. We appreciate your support of the students who are part of our Environmental Professionals Network community. If you have questions or have interest in contributing to this program, please seek out Joe Campbell or Molly Berger, who's at the front desk managing the EPN registration process. Sponsored students were notified in advance who their sponsor is, along with their sponsor's employer and title. With all the students, will all the students in the audience please stand, and let's just get a sense of how many of you are here. Great. We've been doing the EPN long enough now that it's interesting to sort of see the students rise here, and now we have some students that were rising 5 or 6 years ago now amongst us. So it's wonderful to sort of see the baton pass, and we have a wonderful community here in Central Ohio that we're glad to welcome you into. I hope you've had a chance to visit with your professional. One of our goals with the network is to sort of provide opportunities for people to meet and learn learn a little bit about each other. So hopefully it ended up being a good experience. We'd love feedback on whether you found that this a successful effort. 1 year ago, nearly to the day, we hosted Dr. Kathann Kress. She talked about issues related to water quality, agricultural runoff, and harmful algal blooms, and the important role that our college and school have in providing research, teaching, and services to address these issues, to help address address the problems and provide the conversations and context to supplying solutions within our state. I'm tongue twisted today. I'm sort of like I bike too fast, I guess. So. Water quality issues remain, and there continue to be significant impairment of our state waterways, including in the open waters of western Lake Erie. Today, we recognize that we aren't alone in dealing with these issues across the state. Our panel will compare the experiences of Chesapeake Bay, Grand Lake St. Mary's, Sandusky Bay, and right here in the city of Columbus. In a minute, Dr. Chris Winslow, director of the Ohio Sea Grant College Program and FT Stone Laboratory Center for Lake Erie Research, will provide an overview of what the Ohio EPA's definition of impairment means and the science and research on this since 2014. He'll explore some sources of nutrients driving bloom formation and discuss the behavior changes we need to see within the Lake Erie watershed. Here in the School of Environment and Natural Resources and at Ohio State, we have a strong and growing relationship with Stone Lab and Ohio Sea Grant Program. Over this past summer, we had 17 students from SENR alone take courses at Stone Lab, Even one of our panelists, an alumni of the school, recalled her time at Stone Lab as an undergrad student that made a major impact on her. In a lead up to our program today, she shared that her Stone Lab class and many summers she spent as a camper and counselor at 4-H Sea Camp on Kelly's Island focused on water quality studies taught by Sea Grant staff, and field trips to Stone Lab were among her favorite memories as a student. I bring this up because Stone Lab is a tremendous resource, and we're excited about some of the opportunities we're exploring in the school and here at Ohio State to really make that an even stronger instructional resource. As we grapple with environmental issues in the state, I think it's critical that we sort of take advantage of these resources and socialize people to the needs of the state, and Stone Lab is a great repository for that. In light of that, we've actually, this next weekend, we're taking the entire new first-year class from the school up to Stone Lab to socialize them to the resource at the lake. I know many of you have had great exposure and experiences with Stone Lab, and so we're sort of like touting Stone Lab a little more aggressively just to make people aware of this great resource and the opportunities it provides. With that introduction, I'm going to turn it over to our moderator, Dr. Winslow, whose a very impressive biography is included in the program and who can share more about our speakers today. Thank you.
Thank you, Jeff. Excuse me. Thank you, Joe, for helping organize this. So I'm going to get right into my portion of the presentation. And as you are all probably well aware, we have now designated the open waters of the western Lake Erie Basin impaired. And so it's important for programs like Sea Grant and Stone Lab to get out and kind of talk about what this actually means. And I'll start off by saying impairment does not mean don't use the lake. If you're not familiar with the EPA process, basically every 2 years the state sends forward water bodies in the state that they feel aren't meeting their water quality standard or their designated use. And so we were looking to find that criteria for the western Lake Erie Basin. Again, this does not mean that the lake is off limits. It's still a jewel for the state, and I encourage individuals to find time to get up there. You'll see the research team that was here. So basically, I received a call from Director Butler from the Ohio EPA and asked if I could pull together a team of individuals that could help us come up with this criteria for designation. And clearly, all of these names jumped off the plate because these are individuals that are key in all the work that's going on in Lake Erie right now. And we definitely had interaction from the federal EPA while doing this process. Here's what we're talking about, just real quickly. This is an image prepared by the Ohio EPA. So we're looking at W2, which is this light green region. Laser pointer doesn't seem to be working there. Let's see if we can do it this way. Technology, right? In this light blue or light green region here, so that's basically anything that's greater than 3 meters in depth. It is only the Ohio waters. This is an Ohio designation, and it's west of Sandusky Bay, which is this S2 region that we're talking about right here. So when we try to consider a criteria on how you might list this body of water as impaired, these are the first things that jumped up. You could do a measure of chlorophyll. You could do a measure of the actual toxin that is on most people's radar, microcystin. It's the toxin produced by microcystis. But you could also do bacteria cell counts. So how many cells are you finding per milliliter? So as a team, we sat down on multiple occasions to discuss these. And quickly we found out that we would no longer recommend chlorophyll. And the reason behind that is chlorophyll is not a pigment unique just to cyanobacteria, but it can be found in many algae. And so basically it does not correlate directly with cyanobacteria biomass. The other thing is, those of you that don't get on the water, it's a very difficult thing to measure. Not only quantitatively, but also this thing you're measuring, this pigment you're measuring, will be located in multiple places in the water column. So it can be found at the surface, at the bottom, or it can be mixed throughout the water column. So I'm discussing this point in 30 seconds for you, but there was a lot of deliberation on why we dropped that criteria off the list. The next one, number 2, is microcystins. We're calling this a second-tier metric. And the reason why it's second tier is because more analysis needs to be conducted to figure out what we get from measuring this toxin. In a nutshell, though, this would be the only direct measure of human health risk. So this is the toxin. So really, when we talk about harmful algal blooms, yes, the presence of these green blooms is not ideal, but it's more the toxin associated with those blooms. And so this is the only point measure. Now, the problem with that, in these sub-bullets I'm pointing out to you, it is a point measure. And so going out and sampling that lake for this toxin depends on where you're at. And so again, I'll use this laser pointer. If your latitude, longitude for a sample site is right here, you're missing the bloom that's just a couple yards or, in some cases, feet to the right. And so it's a very patchy thing to measure. And also we're finding that this is not the only toxin that can be detected in these blooms. And so there are other toxins besides microcystin and the 140-some congeners of that toxin. The importance for thinking this is a second-tier criteria is also, though, because what we're going to fall on next is that what we ended up picking as that criteria is satellite data and measuring the cells per milliliter. The problem is, and you'll see in some of the images that I'll show, is that clouds can block out the ability of that satellite to pick up an image. So this is clearly a second-tier metric. I will say, even though it's been quote-unquote tabled for right now, there is funding through the Ohio Department of Higher Education on what a scum is. And so we're trying to actually go out there and figure out how do we determine when the bloom is so thick that it forms a scum on the surface. Right now, it's just an eyeball test for the different researchers and agencies that are out there. So in 2018 and 2019, we had some work in 2018, and we'll continue that in 2019. And then ultimately, we're going to try and correlate the scum information. So when you go out and measure a scum in real time, what does the imagery look like in the satellite? So clearly, we're not completely disregarding microsystems, but we need some effort in that space. Before I get to the final criteria, which is the satellite data, I want a key reminder here. We need to remember that small blooms does not equal small toxin load, and a large bloom does not equal large toxin load. And so we've got to work on this science right now. I will tell you there is a NOAA EcoHab project that's being funded right now, and the goal is within the next 3 years is to not only have a forecast for bloom size that's put out in July, but also have a forecast on likely toxin load. And so we're getting to a space where we're a little bit better at that. I do want to mention when I get to the next slide, when a satellite picks up these blooms, roughly you're seeing 2,000 cells per milliliter of these cyanobacteria. We can say that even though small bloom doesn't mean low toxins and large bloom means high toxins, if you can detect it with a satellite, toxins are clearly present. So 10 or 20,000 cells per milliliter and scums, you are going to have toxins present. And so moving on to the next slide, the image you're seeing with the lake in the rainbow colors, basically that's the satellite image that comes back. What this is showing for all of these years, and if you can't see the font where it's at right now, this starts in 2002 and rolls all the way to 2017. Warm colors mean high toxin loads, and cool colors mean warm colors mean high biomass, cyanobacteria loads, cool colors mean low cell counts. So 20,000 cells or more, so 20,000 cells is the purple color. When you get up around the green colors, you're starting to see 100,000 cells per milliliter, and the dark reds are when you're going to start seeing scums. And so what we did is under Annex 4, which is under the Great Lakes Water Quality Agreement, that annex was calling for a 40% reduction in phosphorus relative to the year 2008. So 2008 was a wet year. It drove a substantive bloom in that year. I can circle it right here for you here. So we're looking for a 40% reduction relative to that year. 2004, which is this year right here, and 2012, this year here, you'll see they fall on that target bloom line. So this is what we would like to see the bloom as far as Annex 4 is concerned, as far as the amount of algae out in the system. And so when we were doing this satellite cell count, what we did was we averaged for 2004 and 2012 to see what that bloom would look like. Because you can see in 2004, it's going to be larger bloom, but many cool colors. And in 2012, it's a smaller bloom, but there's a lot of high-density color in here. Plus, they're located in different regions of the lake. So what we're shooting for is how do we know when we can say the lake is here or better? And if it's there or better, meaning less bloom, we would say that the lake is not, quote-unquote, impaired. So let's get to how we did this. So we broke up the bloom season into 12 10-day frames. So starting in the 1st of July and running through the end of October. Within this, again, we averaged for each one of these 10-day frames what percent of that W2, remember that shape file, what we're calling the open waters, for each one of these time frames, so number 1, July 1st to July 10th, what was the percent cells covered across the average of 04 and 12? Okay, and so that's what we were looking at as kind of our target. We want that percentage of cover in this open waters or less. And so what we basically came to is these are the averages. So if you're looking for that first time frame, and I'm just using the date that's the center of that time frame, 6% of those cells within that open water in 04 and 2012 would have had that much covered in algae. And you can see the peak of the bloom starts basically in August and runs through September, with the highest parts being late August and September. So we took this peak window and basically said, on this data, if you had 30% coverage of that shapefile, that W2, that open waters of Lake Erie, or more, we would call that frame impaired. Okay, so one of these 12 frames, if it was over 30, it would be called impaired. Okay, so these two right here would be called impaired in that scenario. Now, I'm using impaired with a small I because what I need to make clear, and many of you in the audience probably know this, is that the way the bloom looks from year to year is very different. So if you have a wet year, you usually have a large bloom, and if you have a dry year, you usually have a small bloom. And so we need to take into account year-to-year variation. So when I say impaired with a small I am saying is that year itself have too many 30% violations. But then we need to talk about what we call the big I, or open water lake impaired. And what we had basically come to the conclusion that if you see 2 of 6 years, if any 2 of 6 years in a 6-year rolling window are little I impaired, then the entire Western Basin open waters is impaired. And so I can show you what that looks like on this slide. So these are the same numbers you saw before to give you that 30% threshold number we're looking for. And these are the years through time. So again, if you look at low years like 2002, 2005, and 2007, here you'll see there were 0 impaireds in that year, 0 here, and 0 here. So when it's a small bloom, we see 0 little I impaireds. Okay? You will see in our 2 target years, in 2004 there was only 1, which is good. That's what we want to get to. So it's less than 2 impairment or less than 3 impairments. And then 2012 had 2 impairments, so again it's less than 3 frames violated. But if you look at all the frames that I have highlighted in blue, every one of these years, 2003, which you can see was over the target, 2008, starting here, and running basically all the way through 2007, there were more than 3 frames violated in each one of those years. And so 08, 09, 10, you'll see as long as there's a number greater than 3 in that scenario, that's what we're saying is that's a little I impaired. And if you see more of 2 of those, 2 or more in a 6-year rolling window, the big lake is impaired. And what I did is project this into the future, so this is 2017, you would need to see 2 frames violated in each one of 18 through 21 for this lake to fall off of EPA's impairment designation. So what it's telling you is we need 4 good years in 18 through 21 in order for this to fall back off the impairment list. So I will leave that there. I can take questions during the panel or after the presentation, but I want to get into what we kind of know today. These are the 5 Great Lakes. As you can see, Lake Erie is the shallowest of those 5 Great Lakes. It's the warmest, it's the southernmost. And so with this, basically what it's telling you is you have conditions ideal for blooms as far as temperature is concerned. Also, what you'll see, because of the volume of this lake, you don't have the ability to say that phrase, the solution to pollution is dilution. Any nutrients into this system can be concentrated. Additionally, I want to show you land use. So what you're seeing here on the vertical axis is the percent of land used for these different types of activities. I put a box around Erie to draw our attention there, and I'll quickly tick through here. We have the most urbanization in our watershed, so the most people, and as we know, we contribute nutrients to these systems. We have the first in ag, just ahead of Ontario's watershed. We have the least amount of forest, and the bar on the top represents wetlands. Not only do we have the least amount of wetlands, but I put the number 10% up here because it reminds me to tell the audience that we have about 10% of historic wetlands remaining. Okay? So what this shows you through urban nutrient inputs and suburban inputs, ag inputs, not a lot of wetlands to filter out these nutrients, we have a system that has high nutrient inputs. Just to show you some pictures of what this can look like, 2011, some Canada geese out by our islands. Not Canadian geese, they hate when you call them that. Canada geese out by the islands. Colleague of mine, Dr. Richard Krause, and his family out by Marblehead, so this is near the Lake Erie Islands. Is this just a Western Lake Erie Basin problem? Of course, I'm leading you with this slide, but in this picture, you can see the entire Western Lake Basin here, and half of that is covered in a bloom. But I will tell you in some years, depending on the size of that bloom, it can make it out east of Cleveland and can also be dotted along the Canadian shoreline. So what I'll go to also leading you with this question, is this just a Lake Erie problem? And the case is no. This is a state, a country, and even a global problem. And this is why I'm excited to have this panel, because we have perspectives from 4 other pockets across 3 from the state and 1 from Chesapeake Bay. But this is just a simple internet search with the HABS phrase and then Ohio. So let's talk about some of the research that's going on right now. We're currently managing with Ohio's Sea Grant, tremendous help from the University of Toledo on this, NOAA dollars for research, and the Ohio Department of Higher Education funds for research. I don't have time to talk to you about the 70-ish projects that are going on right now, nor do you have the patience to hear it. But I'm going to talk to you about the large thematic areas that this research is currently going into. So the first thing is that we're providing information to produce safe drinking water. So tons of projects are going on right now that help water treatment plants remove those toxins from the system. Comparing the dosing of powder or granulated activated carbon, using UV filtration, bubbling ozone into the water. We even have organisms that we've found in the lake that either attack the cyanobacteria or degrade the toxin that we're bringing into our water treatment facilities. We're also working on human health. In general terms, we know that this toxin is a liver toxin, but we now have research to say in people that have pre-existing liver conditions, there is a potential for cancer-causing effects of this. We're seeing some kidney damage. We're seeing dermatological impacts. Even simple things as a way to test whether you've been exposed or not. If you went to a beach and felt sick the next day and you remember the water being green, we're getting close to that point where we can now take blood or urine samples and actually detect that toxin. That seems like a trivial thing, but once that toxin is ingested, it's metabolized to a different form. So we needed to figure out what form of that toxin or what breakdown we were looking for in those biological samples. We've also seen how we know now the bloom behaves. For example, we now know there are 10 genes that drive the ability to produce toxin. You might say, again, is that trivial to know the 10 genes that are there, but it allows us now to go and take a sample from that lake and figure out what percentage of that population has the ability to produce toxins versus the inability to produce toxins. We now know a better idea of when the bloom is at the surface versus mixed throughout the water column, and we know what kind of impact things like nitrogen have. We always talk about phosphorus inputs to the system, and if we control phosphorus, we can control the blooms. We now know that nitrogen drives toxicity. Okay? The toxin itself is about 14% nitrogen by weight. The cyanobacteria cell itself is only about 7% nitrogen. So it's nitrogen expensive to produce that toxin. All of that work came out of this harmful algal bloom research initiative. The last thing is addressing nutrient runoff, and I will basically say that this is probably the space that we've put the least amount of time to date right now. There's a reason for that. If you look at these four things, Annex 4 is calling for a 40% reduction by 2025. Okay? But we don't have the luxury of waiting until 2025 to figure out whether we can turn our faucets on or not, how this toxin is impacting health, and what that toxin does in the water. And so when we undertook this research initiative, we clearly went through a triage approach. The top three things needed to be addressed yesterday, and so that's where we put a lot of our effort. But I'm excited to say a lot of that research effort is now switching to this nutrient runoff component. So $3 million worth of projects have been completed. Again, some of this is NOAA funds, some of this is Ohio Department of Higher Education funds. There's about $3 million ongoing right now, and there's more to come. I actually had a meeting last Friday with the leads of our agencies, Ohio EPA, DNR, Health, and Ag, to help them direct the priorities of the next set of research projects. So we have about $2.4 million that we're looking to allocate, but we need to have that driven by agency needs. And so that's where we are right now. I truly can't say enough about how collaborative this has been. Every institution on the bottom of this slide has received funding either as a PI or a co-PI. Could not have managed this amount of dollar amounts without the help of the University of Toledo. But more importantly, perhaps, is you're seeing the agencies on the right-hand side. All 4 state agencies have been actively at the table, setting priorities and reviewing proposals. We've had a lot of federal support that you're seeing on the left-hand side, and clearly a lot of NGOs at the table. National Wildlife Federation in the middle on the left, and TNC on the right. And then clearly the ag community has been involved. Farm Bureau is just one logo up here, but we've had the pleasure of working with a lot of farmers. And that drives home this last point, is that you need collaboration to set priorities, and also to share the information that you learn from these research projects. So the farmers, the academics, the agencies, and many miscellaneous stakeholders are at the table. I want to get to other speakers, but I definitely want to talk about what we do know. So there are some knowns out there about nutrient inputs to the system. So the first thing we need to know, since the mid-'70s, we've seen a 75% reduction in wastewater treatment plant input into the system. So after the Clean Water Act and Lake Erie being declared in the late 60s, early 70s, we invested a lot of federal dollars into upgrading the wastewater treatment plants along the lake. So right now, if you measure the phosphorus coming into the western basin of Lake Erie, only about 9% of it comes from these wastewater treatment plants and industry, permitted facilities, point sources. CSOs gets a lot of attention. We've looked at these CSOs. We have measurements for these CSOs. Less than 1% of the phosphorus in this year that I have here, 2013, came from CSOs. I am not saying that we don't address CSOs because of the bacterial and virus loads associated with these, but clearly we shouldn't be addressing CSOs because it's a phosphorus driver for blooms. It contributes, but it's clearly not driving. We know that septic systems, these are monitored by the Department of Health. We know that about 4% of all the phosphorus coming down the Maumee River into the Western Basin is coming from this source. Scott's Miracle-Gro, we think about our urban and suburban contributions. We now know since 2013, Scott's, a fertilizer company, removed phosphorus from its maintenance lawn fertilizers. And so now we know that when we apply these lawn fertilizers, that we're not adding more phosphorus to those urban and suburban centers. And last but not least is 3 to 7% of the phosphorus in the system is coming from inside the lake. This is important to mention because two of the systems that are going to be discussed today, Grand Lake St. Mary's and Sandusky Bay, this is not the case. So when we go out there and measure the nutrients coming from the bottom of the lake up into the water column to drive these blooms, we've measured only about 3 to 7% of that total phosphorus load is coming from the lake. I put verses at the end of that bullet because we know for Grand Lake St. Mary's and for Sandusky Bay, if you totally shut off that nutrient input, you're going to have blooms well into the future because most of that phosphorus is already in the system, is being moved back up into the water column. So that's a quick run through in the nutrient sources today. I'm actually going to end my PowerPoint presentation at that point, and I'm going to bring up our first speaker that will sit on our panel later. And what we have for us right now is Rich Batiuk. So he is recently retired and really excited about that. I talked with Rich about that earlier today. He was, though, during his time, Associate Director for Science Analysis and Implementation with the U.S. EPA based out of the Chesapeake Bay Program Office. He pulls his master's degree from American University. It was in environmental toxicology. He has his BS from the University of New Hampshire in environmental science. And really, Rich's role was to integrate the science from multiple partners into decision-making and basically trying to accelerate the nutrient reduction and sediment loading into the Chesapeake Bay system. And so I will get to Rich right now and let him bring you his discussion about what's going on in Chesapeake Bay. Rich.
Well, welcome from the East Coast. Here to tell you that, yes, in fact, you can live with an impaired water body. In the case of the Chesapeake, 6 different states, Washington, D.C. In the Chesapeake Bay region, we had people still remember the War of Northern Aggression between Pennsylvania and Virginia and stuff. So you can actually get your state partners to work together. You can work with your local partners and others. And in the Chesapeake, after 30-plus years, our underwater grasses are coming back. Our dead zone is shrinking. Our rivers, hundreds of them, are actually running cleaner out there. Are we done yet? Absolutely not. We still have got work in our cities, in our streets, in our farms, in our forest area out there, et cetera. But I'm saying if you work together, you can make it happen. But Chris, some of the slides I saw up there, we haven't seen those conditions since the 80s. So, gosh, my heart was warmed coming back here and saying, gosh, we've made some progress, guys. So the challenge is certainly there, and I want to work you through at least 5 lessons learned that we had in the Chesapeake that I want to share with you all and talk about how that works together as well. The first and perhaps one of the most simple, but certainly for an interstate body of water, and that is agreeing on what is clean water. Agreeing in a fashion that's scientifically valid, but is understandable by your public, your local elected officials, can be legally enforced out there, can be achieved, and can be simply described for local newspapers and local audiences out there as well. Certainly there's complex science underneath there, but folks can understand clear water and underwater grasses and the need for good places for fish, rockfish, oysters, sort of our holy trinity in the Chesapeake itself. So getting that definition of clean water, because like you all, we're asking farmers, we're asking homeowners, we're asking municipal authorities hundreds of miles away from those tidal waters to do something for their downstream neighbors. So getting that definition of clean water and getting everybody to agree to it, now the discussion is how do you get to that particular piece. The second seems again simple, and that is take what that water body can withstand and divide up the responsibility down to a more as local a scale as you can possibly politically and scientifically do that. 64,000 square miles, 6 different states. We recently had our governors agreeing of not just how do you divide it up by states, they're agreeing how do I get it to individual counties, how do I get it to a small watershed, how do I get it to an individual city out there as well. That's a lot of science, that's a lot of politics, that's a lot of trust among partners, whether they're at the headwaters or further down right on the Chesapeake itself as well. And we can discuss how we were able to get to that particular point and not fight over the mechanism, but then who does it, how do you equitably divide it up there? Not equally, but equitably divide up the responsibility among, in this case, very, very local partners out there. Third, this was a tough lesson, but it actually came from our state partners, not top down from EPA, and that is hold everybody accountable. What you're seeing is actually something we publish every year. The public is interested in it. The governors don't like it, but they understand then they need to do it. And that is, we look across the different source sectors, across our 6 state and district, 7 district partners, and talk about, in this case, what is the oversight level that the federal partner are bringing to our state partners that are not carrying out the actions that they agreed to. What the governors agreed to about 10 years ago was every 2 years they would commit to the public that here's the money we're going to bring to the partnership, here's our additional legislation we're going to go after, here's the programs we want to put in place, here's the number of cows we're going to diaper, here's the streams that we're going to restore, hold us accountable, public, and if not, we're going to come back to you and tell you why we didn't do it. Or in some cases, like Pennsylvania, they're pretty far behind. And their downstream neighbors say, hey, listen, I'm getting my farmers to do the following. My wastewater treatment plants are upgrading. You guys have got to hold those guys responsible because I can't clean my waters up if I'm in Maryland, Virginia. Some folks might say, wait, that's overreach, et cetera. No, this actually came from our partners, our advocacy groups, our state partners and others, and that is everybody's got a fair share, hold them accountable to it. There's certainly information behind there that we can talk about, but that accountability all of a sudden gets everybody at the table, keeps everybody not, so they're not looking over their shoulder, but they're looking ahead to get what needs to be done, and they know that others are going to be essentially prompted or forced to move in that particular direction. Monitoring. I know that you all have, you're fortunate to have that as well. We put together a monitoring system that's now in its 4th decade. We're not only just looking at trends. My neighbors can talk about trends in water quality out there and rockfish, et cetera, out there because of integrated monitoring systems in the watershed, in our case, across the 4 sets of tidal waters. We've moved on to explaining, well, that phosphorus that looks like it's saturated on the eastern shore in our ag systems, is it actually moving? Is it moving in the right direction? What about groundwater? Can we give credit to folks and farmers in the Shenandoah? Can we give credit to towns up in the New York portion of the basin because of what they've done out there? So it's not a matter of saying it's up or down. It's actually explaining what we're seeing out there, and it's being used to modify, actually, what are the next steps we need to do? Can we move away from a particular area in a particular source sector and turn our focus somewhere else? And then finally, this is a quick snapshot of our 30, 40-year history as a partnership. State, federal, local partners, business community working together. Has it been hunky-dory all the way through? Absolutely not. It is tough to bring so many different interests from such a wide geographic area. But one of the things we've learned, and you can see in the dark blue colors, and that is science evolves, politics evolve, understanding evolves. We then use political agreements across the 6 states in the district with the federal partners and local partners at the table to modify, to adapt to new information, to build it into our political agreements, bring in the new science. So our scientific community knows that we're going to open up our political agreements every 5 to 7 years to then adjust it. But our local elected officials know that in the next 5 to 10 years, here's the expectations, we're going to move forward in doing that. So that ability to then evolve, adapt, and bring that information in there allows you to respond to climate change and changes in fisheries and changes in agricultural practices out there, new technologies in wastewater and septic systems. Build it into your system, connect it in there, drive forward, and then continue to bring that in there as well. So as I said, we're fortunate to have had about a 40-year history of working together. You can actually see that. We had a 50% increase in population over that time period. If we had held steady, that would have been great. We're actually seeing the system responding. My neighbors are seeing it. My watermen are seeing it. My farmers are seeing it out there as well. It can be done, but there's a lot of lessons learned in there that needs to be taken, and it's got to be, you got to hold in for that long-term process as well. But you can get there and see what happens. Particularly when you retire, just as the Chesapeake Bay is coming back, you can walk away, grab that fishing rod, and say, oh my gosh, I got to go out there and test those fish. Thank you.
Great. So thanks for that, Rich, your comments. Next, I'll call up Theresa Dirksen. Theresa is located in Mercer County, so she's the Agricultural Solutions Coordinator. She got her bachelor's degree from University of Toledo in civil engineering. And basically, Theresa's role is to try and work on alternative methods from newer management, looking at how we're placing best management practices on the field, excuse me. And she's also been responsible for bringing in about $700,000 worth of funds to help implement those BMPs and do the research in the watershed. So, Theresa.
Thank you for having me here today. I want to start off by basically mirroring what Rich said. It's all about working together, and monitoring is a huge component so we can show that what we're doing is making an impact. So this is a picture of Grand Lake St. Mary's from this summer, and we're seeing the best year we've had in at least 5 years this year. I don't know whether that's due to some of the practices we've installed or if it's just simply the weather we've had this year, but it is great to see some improvement. So if you don't know much about Mercer County and the Grand Lake St. Mary's watershed, we are livestock dense. We've got about 370 animal units per 250 acres, which is quite a bit, the highest levels in the state of Ohio. We also have some of the highest soil test phosphorus levels in the state of Ohio. All that led up to the distress designation of Grand Lake St. Mary's back in 2011. So that brought a whole new set of rules to this watershed and imposed those rules on predominantly our farmers. So as a result of that designation, we currently, and by we I mean the county, the Soil and Water Conservation District is responsible for managing these comprehensive nutrient management plans and writing these plans, working with the producers to get them updated and making sure they're staying in compliance. So we've got about 135 plans within the watershed, which covers about 90% of the cropland acres. So before we started this process, we had about 23%. So we've made a huge improvement. The other 10% is simply either not receiving livestock manure or is under a current ODA regulation. Along with those plans, we did a ton of practices on the farm. We eliminated probably hundreds of direct discharges from livestock operations. So we covered feedlots. We built manure storages to allow us to have enough storage to get to those times when it's most suitable for manure application. We did holding ponds, irrigation systems. Cover crops was a huge push, starting all the way back to 2010. In short, NRCS sunk at least $10.3 million into this watershed alone over 4 years. They did a special project, and that's not including what's been spent since that special project ended in 2014. So it's safe to say that $12 to $13 million have been spent in this watershed for best management practices. So as long with this distress designation, I think the biggest piece and the biggest impact piece has been the education of our farmers. So that one-on-one interaction between the soil and water districts and the farmers, which is happening at least once every 3 years, most likely more often than that, to get them to better understand basically the 4 R's. The 4 R's is what they're promoting in Lake Erie, but that's really what we're promoting here in Grand Lake with our farmers as well. They may not like the rules, but they have adapted and they have accepted it. So they simply understand how to better handle their manure nutrients, which is, I think, one of the most important things. I did want to briefly touch on some of the research that we've been doing. So there's a monitoring station on one of our feeder creeks. There's 6 major feeders, and we have monitoring stations on 2. Which is done, the data's collected by the Water Quality Center out of Heidelberg. And our local university, Wright State Lake Campus, took that data and we looked at the pre-watershed distress watershed condition and then the post-distress watershed condition and tried to correlate that and see if there's been any changes. And indeed, we found there's been changes. So this chart is got a lot of data on it, but I want to point you to the top corner shows the flow. So our precondition, which is about the first 4 bars there, we had almost lower flows than we had our post condition. But what I want to point out is that you can see the downward trend lines on almost all of our nutrients. Even though we had higher flows, we're seeing our nutrients tick down. This is not a linear distribution. This is, and I'm not the stats person, but a very complex model. So the only issue that we're seeing is with the dissolved reactive phosphorus. It did not have the same trend. We actually saw an uptick in our spring loadings And we think that could be due to when the manure is being applied. With the winter manure application ban, maybe we're shifting and seeing more manure go out in the spring, and that's maybe why we're seeing that. So now, how do we improve that? And I think we're in the process of talking about how can we change these rules to improve that spring loading. So again, I've got a ton of projects, and we wouldn't be where we are today without the Lake Campus. They've been instrumental in a lot of this monitoring and helping us prove what's working and what's not working. So in fact, we had a paper published in the Journal of Environmental Quality on that stats data that I just showed you. So feel free to check that out. It's very informative. So we need to continue searching for methods to improve our manure management and our best management practices. And my job has simply been finding new things. What can we do? What kind of technologies are out there to improve manure management and to improve what's going on the land? So with that, I'll move on to the next speaker.
So our next speaker is Dr. George Bullerjahn. He comes to us as a professor of research excellence at Bowling Green State University, degrees from PhD from Virginia, University of Virginia, and then bachelor's at Dartmouth College. George works on the composition of the organisms living in Sandusky Bay, but also their dynamics related to how nitrogen and phosphorus are cycling through the system. Thanks, George.
Okay, first of all, let me thank Joe for inviting me and that kind introduction, Chris. And let me thank everybody who's been working on this and the funding sources. I'm just the communicator. My graduate students, Michelle Nudek and Caitlin McKindles, are really doing the heavy lifting. Okay, so actually, when we talk about cyanobacterial blooms, basically people think of them as a monoculture. That's really not the case. Not only are there different genotypes of microcystis in the open lake, there is a very different bloom that happens in Sandusky Bay down here, which is dominated by another toxic cyanobacterium called Planktothrix. There's a lot of parallels between us and Grand Lake St. Mary's because this is the same organism growing there, and there are a lot of common characteristics with respect to nutrients there. And so this is what they look like. One's a colonial guy, one's filaments. Okay, so if you look at the Lake Erie maximum bloom images, you've seen this before. You see that there's a great deal of interannual variability between blooms out in the open lake. That's a consequence of nutrient loadings from the Maumee River. However, if you look at every single year, Sandusky Bay lights up. And so obviously there's a real difference between these blooms, and you have a microcystis bloom, which is highly responsive to environmental factors, rainfall, so forth in the spring. However, the bloom in Sandusky Bay is always there, and you can predict it happening every single year. The water looks a little different, never forms a surface scum. However, this water may actually look better than a very scummy Lake Erie, offshore Lake Erie, but that water sample was well above the contact advisory. And so if you look at the differences between the microcystis and Planktothrix blooms, really they're different in every single characteristic except the second one, in which Planktothrix and microcystis produce the same toxin. However, one thing I want to focus on, and I guess I don't know how to make the pointer, oh, there it is, where it is this. Due to high rates of denitrification and internal loading of phosphorus in the sediments, and we also see this in Grand Lake St. Mary's, the Planktothrix is really good at persisting in low nitrogen waters, and that the different behavior means that they require different management. So I don't want to go through all the different literature on why Planktothrix is successful in Sandusky Bay, but nitrogen availability appears to be a good one in that there is a lot of denitrification going on, and Planktothrix is particularly good at surviving in an environment in which nitrogen gets depleted. And we have a couple ideas as to why it's able to do that, even though it does not fix nitrogen. So we monitor the lake, monitor the bay pretty regularly. We have a whole boatload of instruments out there measuring flow and nutrients and so forth. One thing that the summation of all our work, hopefully this movie will work, that I want you to see if this works. Oh, and it does. I can't believe it. Okay. We're going to look at a wad of phosphorus coming to the Sandusky River in red. And this Tetra Tech took all our data from all these years and assembled this into this flow model. And how many people think this phosphorus is going to get into the lake? How many people? How many people? Oh, it's going to try. No, it doesn't make it, okay? So the reason being is that there's not only a constriction there, but there's a seiche effect. So first of all, this tells us that phosphorus, whatever phosphorus comes down the river, it stays in the bay, okay? And there's going to be internal loading. Secondly, it also gives a physical partitioning between our bloom, it's like I own it, and the one out in the lake, this microcystis. And so it's a really very distinct system that's much more like an enclosed system than the lake. I can show you all sorts of nutrient data, but N/P ratios, dissolved N/P ratios are often driven well below what we could consider balanced growth, which would be about 16. And so nitrogen gets depleted due to denitrification. Phosphorus is always there. As a consequence, we have a situation where in late summer, if you take water from the lake that's in a bloom situation, add phosphorus to it, nothing happens. If you add nitrogen in any form, you get a huge amount of biomass and a boatload of toxin. So it's a different situation. So how else does this bloom behave? We also know that, without going into too much detail, that the bloom survives well in sediment-laden water. It also if you increase the light intensity at all, the bloom is knocked down quite a bit. And so the bloom is on the cusp of photoinhibition. And as a consequence, perhaps improving water transparency might inhibit the bloom. I really do think that's an ambitious goal, but there are environmental firms in the Sandusky Bay Initiative which are designing plans for sediment control and then expansion of submerged aquatic vegetation, which may manage sediment, increase water clarity, and perhaps photoinhibit the bloom. And so conclusions here, you can read them just as well as I can, and I'm probably running out of time, so that is why Sandusky Bay is different than anything you see out in the lake. So thanks.
Our last speaker before we get into the panel is, and I'm going to try real hard, Carolyn, here. We're going to get this. Carolyn Krzyzewski. Yeah, or Lorraine, sorry, Lorraine Krzyzewski. No, so I get the easy one wrong and the wrong one. She's the watershed manager for the Columbus Division of Water, so she manages 4 of the reservoirs that provide drinking water. What I didn't know until this talk is that's 13 counties that basically fill into those 4 systems. 2 degrees from Ohio State, so 1 environmental science from SCNR, School of Environment and Natural Resources, and then a master's in STEM education here at OSU. So I will turn this over to Lorraine. Yes.
I'm going to try and use this. Okay, thank you so much for having me here today. I want to give a shout out to EPN Director Joe Campbell and Dr. Jeff Sharp for the invitation. Thank you very much. I'm going to talk a little about the drinking water utility perspective. And for our drinking water utility, nutrients, excess nutrients, let me phrase that, excess nutrients can definitely be a problem. So to begin with, I'm going to give a brief overview of our system. We are the public water utility for Central Ohio. We provide water to the greater Columbus area. That includes the city of Columbus and many surrounding communities. Last year, we produced over 48 billion gallons of water to 1.2 million customers. We have 3 water plants, and 85% of our water comes from a surface water source. So you can see in this slide, forgot the pointer doesn't work. The Dublin Road Water Plant is treating water out of the Scioto River, and the Hapcremene Water Plant is treating water out of Hoover Reservoir, which happens to be our largest source. We are within the Ohio River watershed, and you can see right here where our reservoirs and watersheds are located, and it is in 13 counties. And you can also see that our reservoirs and watersheds differ greatly in size and in volume, and that affects the way they function when they get an input of nutrients. Sometimes, like Hoover Reservoir, the nutrients come in and they stay there for 6 months. We call that residency time. But over in the Scioto system, a big slug of nutrients can come in and it may stick around or it may flush through. It really depends on if we get rainfall after that. And the majority of our watershed is outside the city of Columbus. Our watersheds also differ in land uses. They are predominantly agriculture, but over in the upper Big Walnut Creek watershed, we have 25% forest cover. Over in the upper Scioto River watershed, we have more developed area. And we have to think about the nutrient inputs from all land uses, not just agriculture, but developed areas that are inputting a lot of nutrients too. So some of the recent challenges, and these aren't new challenges, but recent things that have put us in the news, we've had a couple nitrate advisories that we issued in 2015 and 16. We've also had taste and odor issues related to algae. And we're always concerned about sediment and erosion because that can affect not only treatment, but the longevity of our reservoirs. But one big difference there, taste and odor issues are aesthetic. That means they affect the smell, but they don't affect the health of our water. But nitrate is a health issue. So we can't have nitrate advisories that is a violation of the EPA standard. It also puts certain members of our population, like children, young babies under 6 months, at risk. So when that happens, we have to issue a press release, and then that gets picked up by the media. And this is an actual map and some of the headlines that appeared in 2016 when we last had a nitrate advisory. Now, fortunately, right now we have the ability to take out nitrate at our Dublin Road water plant, and this is the watershed where we were seeing most of the nitrate issues. So we're using new technology in combination with watershed management programs and real-time and grab sample monitoring within our watersheds to really act as a trifold approach to managing nutrients and being prepared for what's going to come down the pike. So it used to be pretty easy to explain water treatment. I could talk to a 5th grade audience and really get a good understanding. And it's become a lot more complex. I really wish I had a degree in microbiology and had paid more attention in organic chemistry because those are becoming very important in water treatment along with engineering. So what we've done at our water plants, or in the process of doing, is add new technology to our existing system, which gives us, it's like adding more tools to the toolbox. Okay, our old system was effective, but our new tools are going to let us be prepared for what's in the water today as well as what might be in the water tomorrow. This is our new treatment train. And one of the benefits of that is it gives us what we call a multi-barrier approach. So if there's a contaminant that makes it through one step, chances are the next step's going to annihilate that. The cons are, this is a gold standard system. And it's not something that all water utilities are going to be able to afford. So I'm giving you a Columbus perspective, but there are many other utilities, drinking water utilities in our watershed, and they may have challenges with the nutrients that we're fortunately able to take care of. So the primary goal of water treatment is to meet US EPA drinking water regulations and Ohio EPA drinking water rules. And one way we make sure we're doing that is by monitoring both our finished water as well as our source water. And I'm going to move through these a little quickly. In our source water, we use remote monitoring. These are stationary samplers that give us real-time data, as well as grab samples and limnological data. This is showing you where our grab samples are taking place, as well as our permanent monitoring stations. And what this does, the value of this sort of monitoring, is it gives our plant operators, our lab staff, and our administrators some advanced warning. So if we can see something coming, a problem forming, then we can make some operational changes at the water plant, which may minimize the problem. So it's data that we use to make operational decisions. It's also data that we use to see trends. And here's some of our data, just to go through a quick glimpse. Okay, our limnology program is studying algal populations year-round. We definitely have increased tab monitoring required by the EPA, which during the summer months, we're out there once a week. During the rest of the year, it's more like once a month. And algal issues are nothing new for our system. We've had algal populations since the reservoirs were first built, but they can cause problems in our water treatment as well as those taste and odor issues. And some produce toxins, some don't, but that's not the total solution. Treatment is not the total solution to our nitrate concerns. What we've also been working on is watershed approaches, because it is, in the long run, less expensive to treat the water if we can start with healthier water. And so since 1996, we've invested millions in our watersheds to work collaboratively with agencies, state, local, to try and bring BMPs wherever we can, to try and educate farmers. We always bring farmers to the table because we want to educate them, we want to show them our data, and we truly want to be a partner in solving this problem. So these are just some of the programs that we have used to bring money, to make sure that we're maximizing the amount of money we're putting into this. And looking to the future, it's all about adaptive management. I mean, I think there's still so much that we don't know about this issue. It's ever changing, and there's so many interconnected parts that we're going to have to be adaptive. And we're going to have to look at all nutrient sources. So, and continuing to partner. We can't do this alone. That's all I have.
to stay up there, we're gonna go to the council. So at this time, I'm going to call all the speakers up to the couch, and then there's one extra seat over there on the right. We're running a little bit behind schedule here, so I had a series of questions that I was going to start the discussion with, but I think I'll ask maybe one or two and then turn it over to the audience to bring in some questions also. Let's get started here. So actually, as I'm pulling up my questions, one jump to the top of my thoughts here is the fact that we all talk about this important need of education and the need for collaboration and partnership. But I'd like to ask those on the audience, can you identify perhaps what is the biggest research unknown or question that you wish you had answers to going forward for all the different issues we're dealing with in the watershed?
I'd say how to change human behavior. In our case, 18 million people. I mean, everybody looks at the farmers and stuff, but I've got neighbors, I've got wastewater treatment plant operators, I've got other folks. How do we have folks understand, what they need to do, some small behavior change out there, and make it happen?
I guess we'd really like to know what's causing the blooms. And I know that's a very hard question to answer, and it's got a lot of answers, but I mean, that's the number one question we get from farmers every day. Do we truly know what's causing it?
I'm not really sure myself, so I just wish I knew more about what was causing the blooms to occur right now. We know that this is not a new issue. Algal populations have always been in our source waters. Nutrients have always been in our source waters. So what I'd like to know is, is it something in the atmosphere? Is it something in the weather? What is that causative factor that has truly made this become a problem?
My unknown would be how do we predict toxigenicity? And if you look at a bloom, it's a combination of toxic and non-toxic genotypes. Some toxic genotypes will be actively producing toxins, others won't. Can we predict when, and Chris mentioned it, are there projects out there that will address and model toxigenicity?
Good. So one of the questions that we had sent to us is that do folks in the watersheds in all four of these waters feel like we can get to a nutrient reduction through voluntary measures alone? Or is there a feeling that that's not going to be enough?
In the case of the Chesapeake, we tried for about 20, 30 years, strictly voluntary. We ended up with what we call a bay pollution diet. In other words, Mother Nature, like us humans, you can only take so many cheeseburgers out there and not feel unhealthy. So in the case of the Chesapeake, it's a combination of voluntary, it's a combination of regulatory, and it's a combination of how those things actually combine together. And it's not just on the farmer side, it's not just on wastewater treatment plant septic systems, as was mentioned here, even on commercial fertilizer. So I think we've seen you've got to do it, but we haven't required each state to take the same path. What West Virginia does compared to Delaware does, they have a different personality in terms of their farm community, their local governments, their structure. We've taken different paths to try to get to that same effort, but I'd say definitely we've seen over the last 4 decades a blending, but the right blending that reflects that particular community, that particular set of sources, the science, and what they're trying to achieve within their own states.
To be perfectly honest, in Grand Lake St. Mary's, it did take regulation to make the changes that were needed. I don't think we could have accomplished what we accomplished without it. But with that being said, as in regards to Lake Erie watershed, I think if there's enough incentives provided, we could possibly do this voluntarily. And I think we need to be patient, and I know no one wants to say we need to wait another 5 years, but I think we do need to be patient and let some of these practices work.
Well, I very much agree with what the two previous presenters answered that question with. I think it is a combination. And I've listened to a lot of the concerns of the farming community about, how are we going to afford these things? It takes time. And I think no matter if you're representing the agricultural sector or the wastewater treatment sector, I mean, you can't just make money magically appear. And so I think I'd like to see a little more time spent on voluntary approaches, because I think there's still some barriers that have prevented some of the farmers from feeling comfortable with implementing some of those BMPs.
I suspect that regulation will be warranted down the road. One thing that's I think is very, very important to remember is that we know it's a 40% reduction, and also there are a number of very smart people who have developed land use models that will help achieve that 40%. And so there are measures that can be taken to address that 40% reduction. And mindful of that, I think voluntary will take us a lot of the way there, but I think ultimately we'll need some regulation.
And just to add to that, and the audiences that I get to interact with, basically, most feel that regulations are a tool in the toolbox, but you got to be careful when it's implemented. And I'm hearing that across the stage, is that one size doesn't fit all. So if a regulation is going to come in, it has to be a smart regulation, and that you have to understand that when the regulation is placed, there are constraints to those people that regulation might impact, whether it's a behavioral constraint and in many instances a financial constraint on how to move on these things. So I think that's kind of the message that I continually hear. Through all of your talks, you hit on this, but I'd like to ask just, what do you think has been the biggest change in your watershed since maybe 2010? And not just related to harmful algal blooms, because we have a whole different set of watersheds here, but in the part of like pharmaceuticals and personal care products, green infrastructure, clearly HABs and wastewater treatment abilities. So across the board, what do you think has been the most dramatic change in the watersheds you work with over the last, say 7 or 10 years?
In our case, it's moving from a voluntary to a program that's got a regulatory focus on it, and actually watching the system, the investments that farmers, that cities, that townships, that boroughs have been putting in place actually starting to come to fruition. To understand that, yes, that voluntary cost-share-based program has a certain, can work, but when you get 6 different states and the District of Columbia working together, that there needed to be that accountability system. But I think what we've seen, and it's in all the different sectors, that in fact, the partnership-based, collaborative, but with an accountability behind it actually does work. And more and more of our local communities are seeing that that's occurring, that accountability is going to be doing, but it's now going down to that local scale.
I agree. I think we need to have people working with our producers on a local basis. So our Soil and Water's been very active in working with producers, because not every practice is going to work on every farm. And we've created these individualized plans that do work for each individual farm. And I know that's a huge workload for soil and water conservation districts that may not be used to that type of workload. But I think that's the key. And education of how they can do better and what's going to work on their farm specifically. We've gotten grants and we've tried to do these programs where it's one size fits all, and that just simply doesn't work. You've got to look at each individual farmer and know what they need and know what's going to work with them financially, socially, and you just got to be mindful of what they need.
As far as what's changed in our watershed over the last 10 years, we do have urbanizing watersheds. So we've seen actually a loss of some of the agricultural land as it converts to developed land. And that hard surface that's associated with development land means we're talking about stormwater inflows now. And when you combine that with some of the recent rain events, especially those heavier, flashier rain events, that's really kind of changing the inflows to our reservoirs. And sometimes that can mean dilution, sometimes that can mean new pollutant sources to deal with. So I'd say that's been the largest thing. We've actually seen a slight reduction in nitrates in our watershed, and that could be a result of the lost farmland, but eventually I think that's going to come back as our watersheds continue to develop, and that's going to form new problems for us.
I'd say 2 things, changes I've seen in the last couple of years. There's a lot of litigation regarding the removal of the Ballville Dam in Fremont. Removal of that dam has actually had very little impact on the bay. The other aspect is there are environmental consulting firms which are active in developing plans for sediment management in the bay and building nature-based shorelines. The whole entire much of the south shore of the bay is all hardened landscape with railroad tracks and riprap. The plan is to extend a nature-based shoreline that certainly will help a little bit with nutrient management, but certainly it will help with sediment control and the expansion of submerged aquatic vegetation, which will in turn improve water clarity. So there's a lot of activity in terms of plans for the bay in the coming 5 to 10 years.
Great, thank you. And one last question, and then we'll turn it over to audience questions. I was curious, as we've all kind of mentioned in our talks, this idea of the need for collaboration. Do you feel like everybody that needs to be at the table is at the table, and do you think that there's equal discussion across those collaborative networks?
It would have to be one heck of a big tent to get 18 million people under there. So I'm not expecting all of us, including some of my neighbors, even though they've got shoreline on the Chesapeake in there. But no, I think over the years we went from a state federal program to a state federal local program to a state federal business so that we've been broadening our constituency out there. So is there opportunity for bringing others in there? Absolutely. We've got over 1,600 local government entities within the 6-state watershed. We need to bring them at the table. We've got over 600 watershed organizations out there. I've got 75,000 mainly family farmers out there. You got to get most of them out through the conservation district. Is there opportunity to bring others under there? Absolutely. But I think over the years, over the decades, we've built a bigger and bigger tent, and we've got more and more consensus and agreement. Not everybody's singing the exact way, but I think enough to make some tremendous reductions like we've seen in your parts. That downward connection that you can point back to the farmers, you can point back to others and saying, what you're doing on your land, what you're doing in your treatment system is definitely working. Can you do a little bit more here and here? And then we're going to move on to somewhere else out there. So it is definitely working, but it's always a work in progress.
Again, I agree. I think locally in Grand Lake St. Mary's watershed, yeah, I mean, we're all working together. I mean, we're not just doing the on-farm practices. We're doing wetlands, as he referred to on Sandusky Bay. We're doing those natural areas on a lot of our incoming feeder creeks. So it's a combination of the entire community. I mean, we work well with our lake improvement associations. We have monthly conference calls with all the state agencies to discuss what's going on around Grand Lake. So it's truly been a huge collaborative effort. Do I think that more of that needs to happen in the Lake Erie watershed? Yes.
I think collaboration is a very effective approach in two regards. One is education. It's really important for all the stakeholders to understand each other's operations as well as the challenges, and that builds a mutual understanding that this isn't any one particular problem, and we can't point fingers. It's more about this is a community problem that we're going to have to put some community resources towards. It's also helpful to collaborate when you're talking about grants and using a combination of resources to pursue things that one individual or one individual agency might not normally be able to do themselves. So,
With respect to Sandusky Bay, I believe all the appropriate partners are at the table with the Sandusky Bay Initiative, led by the City of Sandusky or the Soil and Water Conservation District. We have the Firelands branch of Bowling Green. You have Bowling Green. You have school districts. We have Nature Conservancy. So. ODNR. So really, the partners are in place, and I think everybody's poised to see this through.
Great. With that, so Joe Campbell's over here with a microphone, and so we'll see some hands raised, and Joe will work his way to you. And as he's walking there, I would just like to echo the comments here. This has been a very exciting time in my job and what I get to do, because most of what it is that interaction with people, and I can clearly see we're not exactly where we want to be yet, but at least we're having the hard conversations that we need to be having. Please.
Hi there. Hello? Is this working? Okay. I have a question related to how do you, when you go about building those networks specifically across regions, so maybe this is a question that Rich can speak to, how do you start to build out the network? Who are the partners that you go to? Do you first look at, the large municipalities and the larger, more prominent organizations? And how does the strategy of engagement then evolve over time? At what point, how do you engage with people? Is it through webinars? What kind of tactics do you use, and how does that change over time depending on the people who are involved?
I think, that's a tough question. If we got 2 hours, Oprah, are we in good shape here? No, seriously, I think first and foremost, you go to those folks that they trust. Farmers, you go to feed operators, integrators, you go to their conservation districts, and you work within the network that they do. You don't try to establish something different. Watershed organizations, the same thing. Wastewater treatment operators, we love our engineers. They only trust other engineers. They don't want a regulator coming into that system. So you build off that, the people that they trust, where they get the information, and you work up through their particular system. And then you make connections, but you always continue to work through their set of eyes, you step into their shoes, and then you work from there, as opposed to trying to be a stranger and working your way in there as well. That's a lot of work across big pieces of country out there. And when you have this label across you that says, warning, warning, Fed coming into the room. Work with farmers out there, work with treatment operators, work with local politicians. It's a tough way to start, but you got to sit down at the table, and they've got to hear that you're listening to them, and that you're also bringing something to the table, and that you're also asking them to bring something to the table, but they're going to end up, when they walk away from that table, with something more than they came to the table.
George brought up the issue of litigation, and I was working for the state of Maryland when the TMDL lawsuits came down. I'm just wondering, Rich, if you could reflect on that. I know there were a lot of funds that were diverted into the development of the TMDLs and monitoring. Looking back, can you say that that was a pivotal point in managing non-point source pollution and cleaning up the bay?
So yeah, when we put the TMDL in place, our bay pollution diet, we were sued, but we weren't sued by any of the states. We weren't sued by any of our state farm bureaus. It actually came from National Farm Bureau. The reason they sued us is they were concerned about what we were doing in the Chesapeake being applied to the Gulf of Mexico, so that we would take 38 states like we've done here. And our administrator and others said, absolutely not. This is tailor-made to the Chesapeake. Our state partners or others actually asked this to happen. Not something to be imposed upon them, but something that they needed to do collectively. We ended up winning all the way up to the Supreme Court. From that history, not one state partner, one federal partner, not one Farm Bureau group, not local government, nobody disagreed with our definition of clean water. Nobody disagreed with how we allocated the responsibility. It was how you were going to go about doing that particular process. So if it was among our own family, there were disagreements, et cetera, but I think there was an agreement that we needed to work forward on that. And we were to the point, not that voluntary work didn't work. West Virginia has actually been meeting their goals strictly from a voluntary perspective. But Maryland couldn't do that or chose not to do that. Two different states, two different approaches. They're being accountable, as you saw up on that, equally across the board there. So in fact, within our larger family, did we have disagreements? Absolutely, but we had a mechanism for trying to deal with them. The lawsuit actually improved it. It got that big gorilla or elephant, whatever you want to call, out of the room, and center stage, pushed it off, saying, hey, listen, we haven't disagreed with it, and up to the Supreme Court said legally it was good. Let's get back to work and clean up our thousands and thousands of miles of streams and rivers. So it was actually healthy, and the TMDL put a little bit of structure in there. It did not take away voluntary, didn't take away cost share, boots on the ground. It made the case for our conservation districts. Forget the Chesapeake. Lancaster County, 800 miles of impaired streams in one county, but they're also a quarter of Pennsylvania's load. They needed help. They've got the attention now.
Good.
Do we have, or are we working on nutrient load goals, reduction goals, by sub-watershed?
So I can actually, unless there's a panel member that has that. So basically within Annex 4, we know the 13 priority tributaries that contribute to the Western Lake Erie Basin. And so we know that for those, the goal for total phosphorus load is, and flow-weighted mean is 0.23 milligrams per liter, and for dissolved reactive phosphorus, it's 0.05. As a metric ton, for total phosphorus, it's 860 metric tons, and for the dissolved reactive phosphorus, it's 186 metric tons. So that is kind of the contribution of the Maumee River. We have targets like that for all of the priority watersheds. Now, for a whole lake TMDL, which is being asked for the Western Lake Erie Basin, that does not exist, but we do have TMDLs within the sub-watersheds of the Maumee and those other priority tributaries. So it's then that next step of going, and if that is the next step that's logical for the Western Basin, that's not my call, but the question is to take that and put it into a full lake load, and what the value add is to that, the resources that would have to go into getting a whole lake TMDL relative to just the individual sub-watershed TMDLs. Those are decisions and discussions that have to go right now.
Is it on? Yeah. Let me ask a question about drainage issues in Northwest Ohio in particular as it relates to petition ditch projects, which have made agriculture productive in that area of the state. And we've had those projects for well over 100 years going on. We got thousands of miles of ditches under maintenance in various areas. Is it time to think that the drainage laws that we have in this state encompass quality as well as quantity of water. And, from my perspective, I think it's time we start thinking about some newer ideas here. Frankly, I pay a stormwater management fee, a public utility fee, every water bill that I pay that contributes to solving some of those problems, whereas in some other areas of the state outside of the urban areas, the residents of the state are not paying or contributing that effort for what they contribute to the watershed.
I'll start by saying I've been involved with several petition projects as a soil and water district employee. Drainage law in Ohio leaves a lot to be desired. There's literally nothing there in rural drainage. So not only does it not address quantity, it really doesn't address quality at all. So yeah, there's definitely improvements from my perspective that could be made. We all know the importance of drainage, and yeah, I think it's something that the state of Ohio should really consider looking at.
I'll address this from a little of the stormwater perspective. Thanks. Working in an urban environment, we're definitely seeing the value of slowing down water, allowing the pollutants to settle out and soak in, and that's one of the reasons why we're using a lot of green infrastructure around the city, also around our reservoirs as a last line of defense before the water enters our water bodies. So I agree that the drainage law in Ohio could be updated to incorporate some of the new drainage management, I guess, options that are available. The negative is that some of those take land out of production, so there's almost a double cost, both in the engineering and the fact that you're losing productive farmland out of that. So I think we have to find the balance between two of those risks.
So with that, we have one last question.
Thank you. For one or all, bunch of us work for Ohio EPN. We typically struggle with what's the best way to inform the customers. So this is a question for all the panel. Like, what do you recommend, based on what you've done, the best way to reach out to the people so they're better informed, they better understand the value of the water, and therefore the priorities of the people changes, which influences the public policies that are dictated either at the local level, state level, or the federal level. I mean, I often struggle with dealing with the residents that I deal with in communities to better establish about a uniform understanding about the value of the water, which is ignored. So with that, I'll just turn the microphone back to Joe.
Couldn't see you over there, but I found is get out of your office, go to sit down with them in their neighborhood, their situation, et cetera, step in their pair of shoes, first listen, understand, engage in a dialogue, and then start to bring in the connection of what they can do to see what you can do. And therefore, you're going to learn, and you're going to then be wiser in your job, and then encourage your colleagues to do that. We've got this thing called the Beltway around Washington, D.C. A lot of my EPA colleagues never ventured beyond that one. They haven't seen the real side out there. I've always encouraged them, until you do that, your credibility is going to be not there.
I just have to agree with what Rich said.
I think we need to continue educating people about water and water quality from a very young age all the way up through adulthood, because you'd be surprised at the number of adults who still think that stormwater goes to a water treatment plant. It doesn't. It goes to the river. That's what all those little signs say. Don't dump, drains to stream. So there's a lot that we can learn about how our water is treated, how water is so important for aquatic communities, and sometimes it's a matter of just finding something that's very important to someone. So whether it's someone who really likes to fish and they love fish, or they like to boat. Sometimes it's not always about drinking water, because people think, oh, they'll just improve it at the water plant. But we can't improve the quality of water in our reservoirs, our rivers, and our streams as easily as we can at the water plant. So we have to think about all those reasons why water is important for our whole community.
It doesn't hurt to start young. Our lab has developed some learning modules for grade school kids in which they adopt a watershed and they look at the effects of nutrient loadings. That helps. That meets Ohio Department of Education standards. Secondly, I'm at absolutely the end of the furthest removed from the public. I'm in the ivory tower. I'm the guy who knows way too much about too little and can't communicate it. And so it always helps to have a link to perhaps a congressional staffer We work with Representative Latta and Marcy Kapter's offices. They're on different sides of the aisle. That's important to have that kind of connection. It also, as a scientist, a lot of the work we do means absolutely nothing unless it's adequately communicated. A good communication piece would be social scientists, sociologists, economists, people who can monetize the effects of what's going on and then can communicate what we're seeing and how improvements could be translated into dollars and really how much it's going to cost.
Great with that. So I'm going to bring up Jeff Sharp for our closing remarks.
Great. I've hosted about 50 or 60 of these EPN panels. I have to give a big shout out to this panel, as well as all of you working in water quality. I am so impressed with your ability to communicate science, your ability to sort of think about how to work groups together. Just what you're echoing, I think a lot of the professionals that you're working in the field are doing an amazing job of sort of like weaving this together. Each of the presentations I saw today were woven together very tightly and very efficiently and communicated very succinctly sort of key points. And I'm very impressed with the quality of environmental professionals out there. So yeah, you do well for representing us all. Thank you to Chris, Rich, Theresa, George, and Lorraine. As is our tradition, we have a certificate of appreciation that we'd like to give to you on behalf of the EPN. That does it for today's program. I'm sure the speakers will be around for a few minutes to sort of visit with you all if you'd like to visit with them further. I do want to bring to your attention our next EPN breakfast. It's kind of outside the box a little bit, but I'm very excited about it. We'll be collaborating with the Ohio Hospital Association, Practice Green Health and Healthcare Without Harm, focusing on sustainability in the healthcare system. The medical system is a huge user of energy and resources, and we're going to be having a great conversation about how we can engage in practices to sort of improve the energy efficiency, the sustainability, reduce the ecological footprint of our healthcare system. So I think it'll be a very interesting topic. If you have an interest in that, please attend and share it with your friends as well. And then further in November, we're going to have the one of the most decorated scientists, Ohio State, Rattan Lal, join us along with Dan and Wave, Dan and Yogurt. They have been doing amazing work in terms of climate change mitigation, and I think that'll be an amazing program. I had a chance to interact with their staff, and it's I'm sure we're going to be very well informed about climate change and agriculture in that presentation. So without any further ado, a big round of applause for our audience.